Bienvenidos, Ushamdi, and welcome. CTS230 Section 841 students at Anne Arundel Community College. This is the first 8-week term, and this is the Scaling Networks version 6 Networking 3 course, which is going to run until the 22nd of October. And this tutorial is going to be on Packet Tracer Activity 2.1.4.4. So let's go ahead and dive in. Now, we're going to be faced with the same challenge as before, where for whatever reason, the text on the switches will not enlarge. So it works on the PCs, it works on the routers, but the switches, it's not going to enlarge. Now, this is an interesting activity. There's also a significant bug in this activity, and thank you to Andrew for pointing this out. So as you can see, for some reason, the completion percentage is already at 8%, although we haven't done anything yet. So let's go ahead and dive in, and you're going to see that we're going to make it to right around 91%, and then that's going to be it. And I'll show you at the end what we're going to need to do in order to have the completion percentage go to 100, even though it's the incorrect configuration. But I want to make sure that you're aware of the bug. Now, this activity should look very, very familiar to you because this is actually the in-class lab that we did last night, the first in-class lab. Not as many PCs, but definitely very, very similar to how we were set up last night. And again, we're missing an inner switch link here between switch 2 and switch 3. So let's go ahead and dive in. We're going to be talking about VLANs, the VLAN trunking protocol, and DTP. Now, this kind of walks us through things here. So configure and verify the dynamic trunking protocol. So in part 1, we're going to configure trunk links, and we're going to use VLAN 999 as the native VLAN. So on switch 1, and let's pull switch 1 up here, and I'm actually going to make this not that large, but we're going to make it pretty big here so that we can see. Hopefully it gives us a little more real estate. Text is still very small, but I will basically give you sort of a play-by-play here. So we're in user exec mode right now. We'll type enable to go to privilege exec, and we want to say show VLAN brief, right? And so when we take a look here, we can see that the VLANs, some of the VLANs have already been created. So VLAN 999 and VLAN 99 have already been created. We're going to be using VLAN 999 as the native VLAN. Again, this is going to be the VLAN that if any traffic that is transiting the trunk link and it's not tagged with a VLAN tag, it will be tagged with 999 as the VLAN. All right, so we've seen that we've got the VLANs here. It wants us to repeat these steps on switch 2 as well as switch 3. So let's go ahead and enlarge switch 2, and let's pull up switch 3 here and enlarge switch 3. And we're going to do much the same thing. We're going to go ahead and go from user exec into privilege exec and give the windows a second here. So we'll go from user exec to privilege exec and say show VLAN brief. And again, this is going to show us that VLAN 999 and the management VLAN are there, which is VLAN 99. We've got switch 2. We'll see the same thing here. User exec to privilege exec, show VLAN brief, and everything is there. Now, remember what we talked about last night. There are 5 VLANs that are on switches by default, and that's VLAN 1, which is your default VLAN, and then 1002 through 1005. So 1002 through 1005 are for FDDI and token ring. You're never going to use those VLANs, right? They're just there for legacy reasons. And then we get into the extended range VLANs, which are 1006 to 4094. Now, what do they want us to do here? They want us to configure trunks on switch 1, switch 2, and switch 3. And again, DTP can facilitate that negotiation. Now remember, dynamic trunking protocol is on by default. So if I was to say show interface gigabit Ethernet 01 and switch port, we're going to see that the administrative mode, again, the default DTP mode is dynamic auto. And we talked about this last night. The reason for this is because you don't want the port to auto-magically try to allow a trunk to be formed. On earlier Cisco switches like the 3550, the default mode was dynamic desirable, and there was a lot of uproar because of the fact that you're basically putting the switch out there, and if the port isn't shut down, someone could plug in and it's going to try to negotiate a trunk port, right? Where with dynamic auto, which is the default mode on the switches we have today, the 2960s and the 3560 V2s that we work with in class, where it's dynamic auto, if you plug two things in, or you plug a switch, one switch into another, and both sides are dynamic auto, it is not going to form a trunk. It's actually going to roll back to a static access port, right? So we're looking at gig 01 here, and if I was to say show run, and unfortunately we can't do show run int, you can see that it's dynamic auto. And so what we've had happen here, and again, this is critical to understanding not just the dynamic trunking protocol, but what is going on by default. So we have switch 1, and we'll say it's connected to switch 2. So by default, these are both dynamic auto ports. And so what's going to happen here is a trunk is not going to form, right? That is going to become an access port because it's dynamic auto, I'll say ACCESS, and that is going to become an access port. And like we talked about last night, if this was a 24-port switch and this was a 24-port switch, what we've just done here is we've sort of turned this into a 48-port switch, and all the ports, and again, we're saying defaults here, right? We're not going to say we've created any VLANs, that everything is in VLAN 1. So what you've done is you've literally just simply extended the broadcast domain. Now, this is a valid approach. Typically, you don't see VLAN 1 used. You'll see a different VLAN, maybe 10 or 20. But again, this is a valid approach where you're simply extending the size of the broadcast domain across that inner switch link because it's not a trunk port, it's simply an access. It becomes an access port on both sides. And so then we just end up with 48 ports, and they're all in the same VLAN. In this case, we would say they're in VLAN 1. And so that is why it leaves it in dynamic auto mode. With desirable mode, it could form a trunk, and then you've got some security concerns if you forgot to shut your ports down, where a switch is accidentally plugged in. Maybe this guy's VTP revision number is 99, and it gets plugged in by accident. The trunk link forms, and remember, with VTP, it doesn't matter if it's a server or a client. If the revision number is higher than the neighbor, what is going to happen? Yeah, exactly. This VTP, if this guy was the server over here, his VTP database and VLAN database, I should say, is gone. And it's going to get replaced by what this guy has, right? So we've got to be really careful when we're plugging things in. So again, back to this dynamic trunking protocol. Dynamic auto, which is your default, it's going to try to negotiate ISL. It's going to try to negotiate 802.1q. And when neither side says, hey, I can do ISL, or hey, I can do 802.1q as my trunking encapsulation, it falls back to an access port. And again, this is why by default, if you were to take a switch out of the box, a Cisco switch out of the box, and plug in a PC into one port here, and one port here, and the ports obviously aren't shut down, the ports are up, right? These two PCs are going to have connectivity to each other. If you've got them on the same subnet, they're going to have connectivity to each other, and they'll be in VLAN 1 because these ports negotiate to access ports, because obviously the PCs aren't going to try to negotiate ISL, and they're not going to try to negotiate 802.1q. And so that is why you see the behavior that you do. All right, so let's go ahead and clear the screen here. And let's follow on. Let's jump back into where we were in this activity. And we are going to go ahead and say switch port mode dynamic desirable. So we'll get into global config with configure terminal, interface gigabit Ethernet 01, and I'm simply going to say switch port mode dynamic. And if I did a question mark after dynamic, you can see it's auto and desirable. That's it. Auto's the default. We change it to desirable, and we can see that the interface is up. How do I confirm the setting? Exactly. Do show run interface gigabit Ethernet 01 switch port. I'm sorry. Do show interface gigabit Ethernet 01 switch port. And there we go. Because we come back and we see the administrative mode is now dynamic desirable. No longer dynamic auto, which means if it's desirable on one side and auto on the other, it is going to form a trunk. And it did right here. Operational mode, trunk. So what is the administrative mode for for the trunking encapsulation? So by default, it was .1Q. And what did it come up with operationally? .1Q. The other command that we could run, do show interface trunk, right? And again, you can see that it's 802.1Q, but it's not hard-coded. The little N in front of the 802.1Q means that it is negotiated. So both of these commands are critical when you're working with trunk links. Now, we haven't gotten to this yet. This is going to be week 3. So next Tuesday, we're going to begin our conversation about spanning tree. And this last section of output here on the show interface trunk command is extremely important to take a look at now and to remember when we go forward. It's the VLANs in the spanning tree forwarding state and not pruned. And then it shows me the interface as well as the VLANs. So these are the VLANs for which this switch is going to forward traffic. And when we start to talk about pruning the VLANs, maybe a VLAN doesn't show up here for whatever reason. That's when this command and that output specifically here at the bottom becomes critical to being able to troubleshoot why you're not able to forward traffic in a given VLAN. And then gigabit Ethernet 01, it shows me the interface over which it's going to be doing that forwarding. So everything looks good, and let's take a look. What happened here? The completion percentage dropped to 0. So very interesting, right? We were at 8% with nothing done. We type the first command in and it drops us to 0. And I think what happens is we run it to 92, I think, is what ends up happening. And I'll show you what you have to do to fix that, right? So we went from 8 to 0, but that's okay. We typed in exactly what they showed. That's great. So now what about the trunk links between switch 1 and switch 3? Well, it wants a static trunk configuration. So switch port mode trunk. We're not going to allow it to be dynamic desirable or dynamic auto. We're going to hard code it as a switch port mode trunk. And this is a Cisco best practice. The other best practice is along with this command, because when we run this command, you're going to see where it says negotiation of trunking, it's going to say that it's on. Even though we say switch port mode trunk and we hard code it as a trunk, it's still going to say that DTP is on. Best practice is to say switch port mode trunk and then switch port no negotiate to turn DTP off. And I know sometimes it can be a little confusing where we're covering material and then we'll talk about best practices, and those best practices immediately tell you to disable those features, right? But they're in a lot of cases on by default. So we want to make sure we fully understand not only how they function in a default sense, or if we had dynamic desirable on, but when we go to turn them off and how we properly turn them off. So on switch 1, which we're still on here, let's get into interface gigabit Ethernet 02, and I'm going to say switch port mode trunk, right? So do show interface trunk, and you can see there that that's the difference. It negotiated the encapsulation on gig 01. That little N in front of the 802.1Q indicates it's negotiated, and then we do not see the little N in front of gig 02 because I said switch port mode trunk, and by default on this platform, which this is a 2960, and our classroom switches, the physical switches in our classroom, behave the same, where 802.1q is the only, or I'm sorry, it's the default encapsulation. So if I was to say switch port trunk encapsulation, you can see it's not even an option here, right? Allowed in native, but 802.1q is on by default on the 2960s, right? So we don't have to say switch port trunk encap.1q. On the 3560s, you would need to specify that if you wanted 802.1q. All right, so we've taken care of that. Do show interface trunk here. Let's bring that up one more time. And so everything looks good. And now the completion percentage is back to 8%. All right, on we go to switch 3. And let's do much of the same. We'll go from user exec to privilege exec into global config, into interface gigabit Ethernet 02, switch port mode trunk. And when I say do show interface gigabit Ethernet 02 switch port, what do we see? Negotiation of trunking is on, right? So by saying switch port mode trunk, and this is often a confusing point for a lot of learners, when you say switch port mode trunk, you're hard coding the trunking mode, or you're hard coding the port to be a trunk, but you are not turning off the negotiation of trunking, right? And it's kind of almost counterintuitive, right? So what we would have to say, and I'll throw it in here, is switch port no negotiate. That will turn DTP off. And then here we go, negotiation of trunking is now off. So to be clear, if you want it to be a trunk port and you want to disable DTP, you would say switch port mode trunk, switch port no negotiate, right? In that use case where you want the port to be a trunk and you want DTP off, switch port mode trunk, switch port no negotiate. If you simply wanted DTP to be turned off, you could turn the port into an access port, right? But keep in mind, once you say switch port mode access, that is going to override all the trunk settings that you have and make that port an access port. And we saw that last night in the example that I gave in class, where we configured the port as a trunk, and then as soon as I say switch port mode access, the mode, the operational mode, it becomes an access port, right? Because remember, by default, and we've seen this, right? So, and you see it here on this 2960, every port, and this supports that comment I made in one of the first video we did, is with a switch, every port on a switch by default is a trunk port, right? They're all configured by default to be trunk ports with that dynamic auto. It's only when you say switch port mode access that the port becomes an access port. All right, so we've got switch 1 and switch 3, so we've done our verification. Everything looks good. So now on switch 1, let's bring switch 1 back up here, and we're going to set our native VLAN. And here's where we should see the ubiquitous or very common universal CDP error that we have a native VLAN mismatch. So we'll say interface range gigabit Ethernet 01-2. And we're simply going to say switch port trunk native VLAN 999. Now, if that VLAN didn't exist, it would be created. And here we see we get a spanning tree error right away, that we've got an inconsistent BPDU because the native VLAN on the other side, and this is for gig 01, the native VLAN on the other side, and there's my CDP message, just like clockwork. We have a native VLAN mismatch. And so that's a problem, right? They have to match, or else, if I were to say do show interface trunk, right, you can see that it shows that it's trunking here. It shows the 999, but we're going to have issues with a native VLAN mismatch, right? So, and take a look at gig 01 here. So VLAN 99 is the only VLAN in the spanning tree forwarding state. not 1, 99, and 9999. And then gig02, the same thing, right? So we get the error for gigabit Ethernet 02, and you can see we're going to end up with sort of unpredictable results, which we don't want. So how do we resolve this? Well, obviously, we're going to go to switch 2 and 3, and we're going to make that same change. You can see they're also reporting the native VLAN mismatch. So let's go from user exec to privilege exec with enable, into global config with configured terminal, into interface gigabit Ethernet 0, and on switch 2, it was, I can't remember the port, let's say do show interface trunk, gigabit Ethernet 01, gigabit Ethernet 01, switch port trunk, native VLAN 999. Now that spanning tree, the blocking with spanning tree will go away, and the native VLAN mismatch error will also go away. And you can see everything looks good on switch 2. Let's come over to switch 3 and go into do show interface trunk. Let's make sure we've got this right. Interface gigabit Ethernet 02. And we're simply going to say switch port trunk native VLAN 999. And there's that spanning tree unblock, right? Because now it's consistent. And so we'll say show interface trunk. And you can see that we've got just VLAN 99 showing up as being forwarding and not in the, I'm sorry, is in the spanning tree forwarding state and not pruned. And show interface trunk. And that was what I was looking for. I was waiting for it, waiting for spanning tree to update because all 3 of those VLANs should be in the forwarding state for us now that we've got that sorted out. Okay, so we've taken care of the native VLAN issue. Now we're on to the VLAN trunking protocol. And again, I like this activity because it walks you through in a method that makes sense because we can't do VTP before we do the dynamic trunking protocol, right? We have to have our trunk ports because those VTP messages that we see, those advertisements and the summaries, those are going to have to go over trunk links. Those do not go over access ports. They're going to go over trunk links. So we've got to sort the trunking issues out first before we get into VTP. But here we are at the VTP section. Switch 1 is going to be the VTP server. Switch 2 will be configured as a client. And what about switch 3? Maybe we're going to do transparent mode. So let's go ahead and walk ourselves through here. So on switch 1, we'll bring this up and we're going to say we'll exit out to global config. And I'm simply going to change the mode to VTP mode server. And you can see it says setting device to VTP mode server. And let's change our VTP domain to CCNA. And it changed it from null, which is the default, to CCNA. And then we're going to set our VTP password to Cisco. Now, very, very important. This is one of the many drawbacks of VTP. Is when I say do show VTP password, there is the VTP password in plain text, unencrypted, unciphered, everything. In fact, if I was to say do show run, and this is the same thing, you can see we've got no service password encryption. If I was to go on to a real Cisco switch, and we don't want that, we want this here. If I was to go on to a real Cisco switch and go into global config, and go into global config and say VTP password Cisco, and it says it's already set to Cisco. So if I was to say do show VTP password, you can see it shows Cisco. And you might be thinking to yourself, well, right, but what if you were to say service, and the reason I'm doing it here and not in Packet Tracer is I don't want to aggravate Packet Tracer in the scoring and have it explode on me. So we have service password encryption. Do show VTP password. Yeah, no, it's still going to show it to you in plain text. So again, do show VTP status. We're even running version 2, right? So we're running version 2, and it's going to show it to me in plain text. That is a huge security concern, right? Huge security concern, which is one of the reasons one of the many reasons that VTP is typically not deployed. And as we talked about last night in class, and I showed you in the CCDP architecture, the Design Professional book, Cisco actually recommends that you do not run VTP, that the risks and the dangers of what can go wrong with VTP, and we'll talk about that VTP revision number, right, wiping out your entire database. And we've got a native VLAN mismatch discovered here. Did I not do show run? Did I not get the interface range right? All right, so it's interesting. We're getting a native VLAN mismatch. So it's 999 here, and it showed switch 2. Did I not? All right, it looks like we missed switch 2. In the global config here, real quick, we were getting that CDP native VLAN mismatch error. We'll get into interface gigabit Ethernet 01. So switch port trunk native VLAN 999. And that should take care of that. And let's do a show run. All right, so it is on there, so that looks good. So we'll go back to switch 1, our VTP server here. And we've set VTP 1 up. So now when we say do show VTP status here, and we're still getting that native VLAN mismatch. All right, we'll come back to that. This may be part of the bug we're seeing. Do show interface trunk. Yeah, everything looks good, so we'll let that go for right now. We'll come back to it here if we have to. But you can see we're running version 2 of VTP. We've got 7 VLANs, version 2 of VTP. We are a server, and by default, the operating mode is server. The domain name by default is null, right? And we've changed it to CCNA. And again, to see the password, we would simply type show VTP password. So let's come down here now. We're going to go ahead and take care of switch 2 and switch 3. And 3, are they both going to be... Okay, switch 3 is going to stay in transparent mode. And we'll talk about the passing of the VTP messages. So let's get to switch 2, who's going to be our client, who is still complaining about the native VLAN. Show interface trunk. Did I do this on the right port? Yeah, so we're good there. All right, so let's get into global config, and we're going to say VTP mode client to turn it into a VTP client. Now, it's still not going to synchronize the database because we have to set the domain to CCNA. And still it's not going to set the database because we need to set finally the VTP password, and we'll set that to Cisco. And now we should see show VTP password, right? Oops, sorry. Do show VTP password. We'll see the VTP password is Cisco, but when I say do show VTP status, we should see, all right, nothing modified yet. What about do show VLAN brief? Which VLANs do we see? We still see VLAN 99 and 999. And we've got this native VLAN mismatch here for some reason. So let's do this. Interface gigabit Ethernet 01. And I'm going to shut the interface down. And let's see if we can bring this out. And no, it still says switch 1 on gig 01, do show run, that we have a native VLAN mismatch, which we don't. So switch port trunk native VLAN 999, and that is correct. So we are going to move, we're going to continue forward here. Do show interface trunk. All right, and we're not, and there we go. So yeah, there's a little, we had to wait for spanning tree to converge. And let's see, do show VTP status. Still not updated. Configuration revision number is still 0. All right, we're going to create some VLANs here in a second. So let's see what happens when we get there. So switch 3, we'll come over to switch 3. And we're going to make this our transparent mode switch. And this is actually your best practice. CCNA and VTP password Cisco. And let me make sure, what mode is this in? Do show VTP status. It should be server. It's already in transparent mode. Okay. VTP password Cisco. Now, the reason that we're setting the domain and the password with version 2, right? Remember, with version 2, it's going to pass along the advertisements irrespective of whether the domain name and the password match, right? With real Cisco switches, that's the behavior. VTP version 2, transparent mode, it's not going to check the domain name and the password. It's just going to pass it along. With VTP version 1, that is the version, right? If you're doing transparent mode with VTP version 1, it is going to check the domain name, right, and the password. And if we don't match, it is dropping that VTP advertisement. It's not going to pass it along and send it out its other trunk links. All right, so we are in VTP transparent mode and we are done with switch 3. So now what we're going to do is we're going to prove that switch 1's our VTP server. We've got this mismatch still, so we'll see what happens here. So VLAN 10, name red, VLAN 20, name blue, VLAN 30, name yellow. Oops, sorry, yellow. And let's exit out here and say show VLAN brief, right? So we see 10, 20, and 30 down here in the bottom of our output. And we still got that native VLAN mismatch, which is possibly going to cause some issues here, right? So if I was to say do show VLAN brief, we picked up red, blue, and yellow. So it did update the VTP client switch 2. Do show VTP status, right? And we get this nice message down here. We see the configuration revision is 6, right? 3 VLANs and 3 VLAN names. So 6 changes were made. So the configuration revision number increments, and then here we go. Configuration last modified, and that is my management VLAN IP, 192.168.99.1. All right, so everything looks good there. We've got our update. Let's see what happened over here. Observe VTP transparent mode. Let's get on to switch 3 and say do show VLAN brief. Remember, it's transparent mode, so it's not going to install any of those VLANs in that VTP advertisement from switch 1. Okay, so how many VLANs exist on switch 3? Well, it's still going to be 7, right? The 5 defaults, 1002 to 1005 and VLAN 1, and then the 2 VLANs that are created here, 99 and 999. All right, so now, and there's a note here, I'm just checking this out. Simulation. Okay, so yeah, so you can forward things with the simulator, right? With this simulator with Packet Tracer, but I typically let things play out. Okay, so step 6, assign VLANs to ports. So on switch 3, there are no assignments. So let's come over to switch 1, and here's what we're going to do. I'm going to say interface fast Ethernet 01. I'm sorry, we're going to do interface range here. Get into global config with configure terminal. We'll say interface range fast Ethernet 01 to 8, switch port mode access, and switch port access VLAN, and what VLAN? VLAN 10. And then interface range fast Ethernet 09 to 16. And we're going to say switch port mode access, and then switch port access VLAN 20. And then we're going to say interface range fast Ethernet 017 to 24. And we're going to say switch port mode access and switch port access VLAN 30. Right? And then we'll say end, and let me make sure that was it. Yeah, so that was everything there. I'm going to do a quick write mem here and save my config. Let's pop over to switch 2, where we're going to be doing much the same. So interface range, fast Ethernet 0, 1 to 8, switch port mode access, switch port access, VLAN 10. And what are 2 best practices we should be thinking about? Yeah, spanning tree port fast, because those are going to be host connected ports, right? They're not going to be trunk links or access ports running between switches. They're going to be having hosts plugged in. And then spanning tree, BPDU guard, enable, right? So both good. Okay, so we're good. I think make sure we're on track here. Yep, so we're good there. So interface range, fast Ethernet 0, 9 to 16. So switch port mode access, switch port access VLAN 20. And again, you could do the spanning tree port fast, the BPDU guard enable. And on this last set, I'm going to give you another command here, interface range, fast Ethernet 0, 17 to 24. You can say, and let's see if it's on here. It's not on here, unfortunately. Switch port host. It's a macro that runs. It's not in Packet Tracer, but it's a great command to know because it saves you that spanning tree port fast command because it does it auto-magically. So if I was to go into interface fast Ethernet, over here it's 102. If I was to say switch port and do a question mark, there's that host. Set the port host. So what happens when I do that? So take a look what it does. By saying switch port host, the macro, right? And a macro is sort of like an alias. I type switch port host, but behind the scenes, it's actually running the commands switch port mode access, spanning tree port fast, and it's disabling if there's any channel group command that was on there for like a port channel. So what does that port look like? Do show run interface fast Ethernet 102. There we go. So then the only commands that we would need to add in after that would be the BPDU guard and then the VLAN that we wanted to access or wanted to put this port in that VLAN. So switch port mode access, switch port access VLAN 30, and we could say spanning tree port fast, right? And we get those messages warning us, be very careful about what you're doing. All right, so switch port mode access and the VLAN command. And so we've taken care of all of that. So verify end-to-end connectivity. So let's get our PCs up here. So PC 0. So we're going to try to ping PC 5. So we'll pull our desktop up and you can see here where the PCs cooperate, the text is enlarged without a doubt. So 0 to 5, 1 to 4, and 2 to 3. So let me get that IP table up here. So 0 to 5, so let's say ping and 192.168 dot, where's 5 at? 10.2. So we're probably going to have to ARP, right? Because we know the IP address, but chances are we don't know the MAC address for PC5. And so right now we're sending an ARP request out basically saying, hey, I know the IP address. If you're 192.168.10.2, please respond back to me with your MAC address. But we don't have any connectivity here. All right, so let's check the port that PC0, and PC0 is 192. Let's make sure we can ping ourselves here, which should not be an issue. And we can. And can I ping? Let me make sure I got that right. 192.168.10 dot. 192.168.10.2, and we cannot ping PC5. So let's take a look and see here. And VLAN 10 should be switch ports 1 through 8 on switch 1 and 1 through 8 on switch 2. So we've got this native VLAN mismatch, which is still bothering me here. And so here's what we're going to do. So I'm going to go to interface gigabit Ethernet 01, and we're going to say switch port trunk native VLAN 99. And then I'm going to change it right back to 999. We're going to shut the port down. I'm going to say no shut, and we still have this native VLAN mismatch. Even though the native VLAN is 999. So in the spirit of packet tracer, I'm going to say switch port mode trunk. I'm going to hard code this as a trunk port because I want to see do show interface trunk. I want to see if for whatever reason, and it shows all my VLANs in the spanning tree state and forwarding. So, because sometimes with packet tracer, it doesn't work the way we would anticipate. So I'm going to flip it to switch port mode trunk, and let's see if our results are any different here. And it looks like our requests are still timing out. Although I'm not seeing that native do show interface trunk. All right, so we're trunking, and that is good. Let's check the switch one side here, which looked good. Show interface trunk. And everything appears to be forwarding, but here's what I'm going to do. I'm going to go into global config interface gigabit Ethernet 01, and let's say switch port mode trunk. Let's hard code it as a trunk to see, and then let's say do ping. Let me see if I can ping across the trunk link over to 192.168.99.1. I think that's me. What about 2? And so I do have connectivity over to switch 2. What about 3? So I can get across the trunk link. Let's see, I assume that the IP addresses are assigned here, and they should be. Yeah, so we're good. So the IP address is assigned. That shouldn't be a problem. We pinged it. Let's make sure on PC 5 here that the IP address is configured. Let's not make any assumptions. It's good there. All right, so I was able to ping across just a second ago from switch to switch. Let's see if the result is any different here. And the request is still timing out. All right, let's see if it's just PC 0 and 5 or if it's everybody. So on switch 2 here, I'm going to pull up PC 1, and we're going to ping PC 4. And let's get those IPs up. So 20.2, so we're going to say ping 192.168.20.2. So from PC 1, can I ping PC 4? And it doesn't look like we have connectivity between any of the PCs. And I've got green lights. Let me do show IP interface brief. All right, my ports are up. 17, 9, and 1. So the ports look up. Do show IP interface brief. No host there, but both trunk ports are up, and then switch 3. And let's say show IP interface brief. Oh, so as I've been doing this, I'm hoping that you're screaming at the screen right now because it just occurred to me what we did and why it's not working. Why can I not ping anything in VLAN 10, 20, or 30? Exactly, and this is what I like to refer to as the fortuitous failure. So forgetting that we had set this in to transparent, it was set in transparent mode, it doesn't have the VLANs on here, right? So we need to create the VLANs. I completely missed that step, and was kind of going down this rabbit hole of what could be wrong on the PCs, or maybe it was the port configuration, when in fact all we're missing here is VLAN 10 name red, VLAN 20 name blue, VLAN 30 name yellow. And we've now added in the VLANs that we needed. Show VLAN brief. There we go. But what we didn't do, and maybe I misread that down here. So this was saying switch 1 and switch 3. So when you look at this, and I guess this is what I was going off of what it said here. So this is an epic typo, because where are the hosts connected? Switch 1 and 2? No, it's switch 1 and switch 2 and switch 3. So switch 1 should be switch 3, right? And that's probably the other reason we're sitting at 73% here. So again, pretty big typo in this activity. So let's get into global config, but nothing we can't overcome, right? A little troubleshooting is always a good thing. Interface range, fast Ethernet 0, 1 to 8. Switch port mode access. Switch port access VLAN 10. And we'll say spanning tree port fast, that way we're not waiting around for things. And now let's pull PC0 up and take a look at that. It's amazing what happens when you've got the VLANs properly configured. So we're good there. Now let's go ahead and say interface range fast Ethernet 0, 9 to 16. And we're going to say switch port mode access, switch port access VLAN 20, spanning tree port fast. So we'll come up here to PC1 and we'll rerun that ping, and it magically works. And now to switch 3 one last time, interface range fast Ethernet 0/17 to 24. Switch port mode access, switch port access VLAN 30, and that takes us to 86%. I'm going to throw a spanning tree port fast in here, and let's pull these guys up, PC2, and we'll go to the desktop, and can we ping? I'm assuming this is going to be 192.168.30.2, and we can, right? So we've got connectivity between not only all of the switches, but all of the PCs as well. All right, and you know what I missed was the transparent mode here. I assume they wanted us to leave it in transparent mode. And yeah, change VTP mode to client on switch 3. So I completely read right by this, thinking that they were going to want us to leave it as transparent mode, because I don't believe do show VTP status. This should still be transparent mode, and it is. So VTP mode, client. Now, my guess is this is going to take us to 92% on this activity. Or 91, okay, close enough, 91%. And so here's where you get into trouble, or here's where the trouble begins. If I say check results on this activity, and we come up to the assessment items, you'll notice that we've got 2 X's here. It says the port mode on gig 01 is wrong for the trunk port on switch 1, and that it's wrong on gig 01 on switch 2. So if I was to close this and we come back over here and look, your immediate thought would be, well, yeah, well, you said switch port mode trunk, and they said over here, make it dynamic desirable. Right? So that's not the problem. I want you to watch what happens here, and this is really, really strange. This is one of the worst bugs I've seen. So if I go into interface gigabit Ethernet 01, and I say switch port mode dynamic desirable, the completion percentage will go from 91, or I'm sorry, 91, and you'll notice it didn't move. So I just set it to what it tells you to set it to, and it doesn't change it. But watch what happens when I say switch port mode access. The completion percentage just jumped to 95. So changing it to an access port, which breaks everything, puts us at completion percentage 95. So you're probably thinking to yourself, yeah, look, you can see right here, we've got issues, right? Switch 2, I'm going to do the same thing. Interface gigabit Ethernet 01, switch port mode, access. Completion percentage, 100%. So, terrible bug in this activity. The only way to get to 100% is to change gigabit Ethernet 01 on switch 1 and switch 2 to an access port. There's only one problem with that. In order to pass traffic for multiple VLANs, it's got to be a trunk port. And you can see we've certainly got issues here, right? Spanning trees working itself out, but we're not going to be able to ping anymore. If I pulled PC0 up and came over here, yeah, we're dead in the water. And we're going to get the same result on PC1 and PC2, trying to ping PC4 and PC3 respectively, right? So again, it's a bug in the activity. The correct configuration needs to be switch port mode. On switch 1, you can say dynamic desirable, and that's fine, right? And I'm sorry, conflict between, oh, and when I said switch port, and interesting, do show run, when you say switch port mode access, look what command it dumped in there, and it doesn't actually show it, but it's giving me a no negotiate error. So let me say no switch port mode access. Huh. Okay, switch port mode. Maybe they want me to force it to a trunk. Yeah, so I've got to force it to a trunk first, right? And then I can say switch port mode dynamic desirable. And it's still saying the no negotiate status is on there. So we're going to leave this the way it is. We've clearly got some issues with packet tracer here, but the correct configuration is that gig01 on switch 1 and switch 2, switch port mode trunk. They need to be trunk ports, right? They need to be trunk ports. But again, the correct configuration is going to get you a completion percentage of 91. Making gig01 on switch 1 and switch 2 access ports is going to give you a completion percentage of 100, but nothing's going to work. So we want to err on the side of the correct configuration here, making these trunk ports. And again, I apologize for ripping right by changing switch 3, and I'm missing it here again, changing it to a client, right? I apologize for missing that, and we're troubleshooting something that wasn't the issue. All right, well, this is going to wrap up Packet Tracer Activity 2.1.4.4, where we took a look at configuring VLANs. We took a look at DTP, the Dynamic Trunking Protocol. We took a look at the VLAN trunking protocol. Remember, there's 3 modes that we're talking about: client, server, and transparent. Remember, there is an off mode as well, right? To completely turn VTP off and not to forward any VTP messages along. So there is an off mode. You're not going to see it here in Packet Tracer, but you do see it on the physical equipment, and we talked about that last night. And we talked about the dynamic trunking protocol modes and the fact that if it's going to be a trunk port, hard code it. Switch port mode trunk, switch port no negotiate. All right. Hopefully this has clarified some things for you, and hopefully it's definitely clarified the completion percentage issue and how you were going to get to 100 there. All right. Thanks so much for watching. I will see you guys next Tuesday evening. Have a great night.